Hello everyone. Let's talk about valency shell electron pair repulsion theory. Let's talk about five basic shapes. So all the following these five basic shapes, a central atom contains only bonds, no lone pairs. Let's go through one by one. So examples are given in the first column, and the second column number of bonds, how many bonds attached to the central atom, and then third column is how many lone pairs on the central atom, and the fourth column is electron group geometry. So electron groups means both the lone pairs and the bonds we together count as electron groups. Molecular geometry means in VSEPR theory, what is the shape of the molecule. Here we consider the bonds and the lone pairs separately. So let's go through five basic shapes. First one is the linear shape. So in linear shape, there are two bonds attached to a central atom. For example, BeCl2. Beryllium is the central atom. There are two chlorine atoms attached. Zero lone pairs on beryllium. So we call it is linear in both electron group and the molecular geometry. The reason is two groups attached to central, we call it linear. So here bond angle is 180 degrees. Both chlorine atoms, BeCl bonds, are in 180 degree angle. The next basic shape, BCl3. BCl3, three groups attached to central atom. There are three terminal atoms, chlorines, and number of lone pairs on central is 0. So we call this shape trigonal planar shape, both in electron group and the molecular geometry. So bond angle for trigonal planar is 120 degrees bond angle. The next basic shape is tetrahedral, electron group and the molecular groups. Tetrahedral means central atom. If you draw the molecular structure, surrounding the central atom, there are four terminal atoms, four bonds attached to central atom, but no lone pairs. The trigonal pyramidal shape, there are five bonds attached to central atom, example PCl5. So phosphorus is the central atom and there are five chlorines attached to phosphorus. Then we call the basic shape trigonal bipyramidal shape. So in trigonal bipyramidal shape, if you draw the structure, you can clearly see there are two types of bond angles. The reason is three bonds are on the plane, like a trigonal planar structure. We call equatorial positions, and the other two chlorine atoms are in axial positions. So if we consider the bond angle, there are two types, 120 for trigonal planar ones, and the axial central and the equatorial bond angle is 90 degrees. So 120 and 90 are both bond angles are present in trigonal bipyramidal geometry. The next basic shape is octahedral. Octahedral means there are 6 groups attached to central atom. Example SF6. Sulfur is the central atom. If you draw the Lewis structure, you can clearly see there are 6 fluorine atoms attached to sulfur, but no lone pairs. So in electron group and molecular geometry, we call both octahedral. Now these 5 basic shapes, 0 lone pairs on the central atom. Let's go and see what are the other additional shapes with lone pairs. Let's talk about some additional shapes. So tetrahedral electron group geometry. So in previous slide, you can remember tetrahedral is 4 groups attached to central atom and 0 lone pairs on the central. Now if we replace one of the bond with a lone pair, then 3 are bonds, 1 are lone pair. 1 is a lone pair. Then tetrahedral is electron group geometry. But molecular geometry, we need to separate 3 bonds and 1 lone pair. So for 3 bonds and 1 lone pair, we give a name trigonal pyramidal shape. Example NH3, PCl3, you are trigonal pyramidal shape. Next one, the same tetrahedral arrangement. Total electron groups attached is 4, but among these 4, 2 are bonds and 2 are lone pairs. So this is like water molecule H2S. They all are bent. Or another name is angular shape. Next, let's move on to trigonal bipyramidal shape. From the previous basic shape, you all can remember 5 groups attached to central we call trigonal bipyramidal shape. Now among those 5 bonds, 4 are bonds and 1 is a lone pair. We call seesaw in molecular geometry. So 5 bonds we replace with 2 lone pairs. Then 3 are bonds, 2 are lone pairs. But total 3 plus 2 together still 5 electron groups. So the trigonal bipyramidal is electron group geometry. However, the molecular shape for 3 bonds and 2 lone pairs, we are giving a name T shape. It's like a letter T. The next one, the same trigonal bipyramidal electron group arrangement. Now we replace the 3 lone pairs and the remainings are bonds. So 2 plus 3, 5 trigonal pyramidal electron group geometry. However, we give name for this linear shape. I hope now you can remember we have a linear shape in our basic shapes. Linear means 2 groups attached with 0 lone pairs like VeCl2, carbon dioxide, they are linear. And another way we can predict shapes as linear is when 2 bonds and 3 lone pairs present like in XTF2. The last two are octahedral electron group geometry. So octahedral, from the previous slide you can remember 6 groups attached to the central atom. Now among those 6, 5 are bonds and 1 replaced with a lone pair. We call it is a square pyramidal shape. So another bond replaced with lone pair, this time 4 bonds and 2 lone pairs. So it is octahedral electron group geometry. However, the molecular geometry is square planar. All 4 atoms here XCF4 on the plane of the square and other 2 fluorine atoms like in above and below the plane. Now with the basic shapes and these additional shapes, let's go and predict the shape around each atom in the given examples. Let's take some examples. There are 3 structures here. Now I'm going to explain the shapes around each colored atom. So carbon, red color, nitrogen, blue color. What are the shapes around this carbon and the nitrogen and so on. First, let's see the first red color carbon. There are 4 bonds attached to carbon and 0 lone pairs. So it is our one of the basic shape tetrahedral. The second blue color nitrogen, there are 3 bonds, 1 lone pair. So 3 bonds and 1 lone pair like nitrogen, it's trigonal pyramidal shape. On the second structure, the red color carbon, 4 bonds and 0 lone pairs. There are 4 bonds, 3 are CH bonds and 1 bond is CC bond. So no lone pairs on red color carbon, it is a tetrahedral, again geometry. The next shape is the blue color carbon. There are 3 electron groups. Electron group means double or the triple bonds, or we consider as 1 electron group. So it doesn't matter double or the triple or the single, it is 1 electron group. These double bonds between C and C, we consider 1 electron group. The second one is CC bond, the other one is third one is CH. So there are 3 bonds, 0 lone pairs. We call trigonal planar geometry around blue color carbon. Let's go on to our third structure. On third structure, the nitrogen blue color one, there are 3 bonds. 2 are NH bonds, the other bond is NC. And 1 lone pair on nitrogen. So 3 bonds and 1 lone pair we call trigonal pyramidal shape. The second carbon is again tetrahedral. There are 4 bonds, 2 are CH bonds, the other one is CN and CC bond. Next, the red color carbon. So here again, the red color carbon has 3 electron groups, or we call simply bonds. So one is CC, the other one is CO, and C double bonded oxygen. So 3 electron groups attached, 0 lone pairs. Again, trigonal planar around the red color carbon. Then the last one is the purple color oxygen. You can see it's like a water molecule, H2O. There are 4 electron groups, 2 are bonds, CO and OH are bonds, but 2 lone pairs on oxygen. So 2 bonds and 2 lone pairs, then we call bent shape. Around this oxygen, the shape is bent, or another name is angular. Now, I hope now you all are comfortable with predicting the shapes around any given molecule. And another important point is, if you have a molecular formula is given, you need to draw the correct Lewis structure. So after you draw the correct Lewis structure, and then you need to predict the shapes. The one more point you need to memorize, understand. If you have the structure, very complicated structure given, first thing is you need to check uh, the number of lone pairs. If the structure is not complete, you need to complete adding lone pairs on the nitrogens or oxygens, whatever the suitable places. First, adding lone pairs to give octet of electrons. Octet means 8 number of electrons. So after you complete the structure, adding lone pairs to give octets for each atom, and then predict the shapes. So without adding lone pairs or without completing the structure, the predicting the shapes can be incorrect. So first complete the structure or check the structure is correct with any octets around the atom, and then predict the shapes. Thank you everyone.